week's topic is quite appropriately reflection, reflection and metaprogramming. So we're going to talk about some advanced techniques. Um, Maybe some of you have already encountered these, maybe many have not. So this is it. So let me start with talking about reflection, and then I'll show you some examples in Java. But what's the idea? What's the conceptual idea of reflection? It's the ability to inspect and even act on the code of the program. So what does that mean? So now we're going recursive, but it's a slightly different form of recursion, right? It's not just a function calling another function. It's a program that is able to inspect itself and even manipulate itself, right? So this is reflection. Just like, the word reflection in human terms means that we kind of think about, the things that happened, right? That's sort of where that word comes in when applied to programming. And the idea was, so the question was why. I will show you some practical applications of this towards the end of the lecture today, and also on Tuesday, on Thursday, I'm sorry. But there's some reasons for why, there's some philosophical reasons for why people were attracted to reflection back in the 70s in the context of Lisp, by the way. But the idea was to, the sort of the philosophical reason for reflection was this, in the context of, let me backtrack. Lisp bloomed in the context of the first wave of artificial intelligence, right? So during the 60s and 70s, when people were very excited about doing, artificial intelligence through rule-based systems mostly, Lisp was the language for artificial intelligence, right? And there was sort of an impression among the people in the Lisp community that you couldn't really emulate human cognition, or you couldn't possibly want to reproduce human cognition unless you had the ability for the programs that you were supposed to reproduce human cognition to reflect upon themselves, right? Because that's what we do, right? We humans have the ability to reflect upon ourselves, and that's a very powerful thing that gives us this extra superpower that almost no other animals have. Maybe none of them has. So this idea to really reflect about what we have done and it change our behavior, right, as a consequence of reflection, was seen sort of as a desired property of where programming was going in the 70s. So that's the idea. So you have a program. When you write a program is a dumb thing, right? We write it and then that's it. We are the creators and the program does whatever we decided it should do. But the idea there is that we could create a program in such a way that it could not only observe itself what it is doing and inspecting at what it's doing over time, but eventually also change what it was doing over time based on what it saw, right? And then basically we, the creators, would be hands off, and the programs would have essentially, awareness of themselves, and they would be, alive, some version of alive. That was the context and the motivation and the hope that was in the minds of many people in the context of Lisp back in the 70s, and that created this idea of reflection. But besides from this philosophical and kind of cognitive reason for why we would want to bring reflection into programming, there's very many practical engineering reasons for why reflection is a good idea, and I will show some of them later on. So for example, proxies, imagine a large interface And that imagine a large interface that wraps around some implementation of some class, right? And you can map each method of the interface. When I'm talking about interface, I'm talking not just an abstract data type, but an actual proxy. So some wrapper. Okay, something that has implementation that wraps another piece of implementation. So those are what's called the proxies. So you could have, you can write proxies by hand, right? So you can map each method of the proxy to the method of the inner class that it's kind of wrapping around. But that is kind of a pain in the neck because you have to write all those methods by hand. Another way is to programmatically program that proxy, right? So you basically write a proxy in a reflective manner that iterates through the methods of the class that is wrapping. And for each of those methods, it does basically something that is essentially the same on all of the methods, calling some log function or something like that, and then calling the inner method. So you can think about making programs that work on other programs. So that's proxies, for example. Plugins is another very practical use of reflection. I will show you some of that on Thursday when I talk about plugins. For software development tools, right? So for example, if you use IDEs, Eclipse, IntelliJ, you name it, Visual Studio, Visual Studio Code, all of those IDEs are programs that load up program texts that are programs themselves. So they need to know, like, the reason why we have, for example, autocomplete in the smart IDEs, or the squiggles, the red squiggles or the yellow squiggles or things like that, that the IDE knows about the code, right? It knows about the methods, the classes, it knows about the syntax, it knows about when things are not quite right. So it needs to know about it. It knows about the programming language and is capable of telling us that something is not right or that something is right, right? So all of those software development tools are programs that work on other programs. And when they are written in the same programming language, that typically is done using reflection. So, a lot of very powerful reflection capabilities that they can take advantage of. Debuggers, test tools. Again, things like JUnit, for example, and many other testing frameworks also rely on the existence of reflection to be able to run certain things at certain times, and debuggers too. So all of that, there are programs that work on other programs, and you have programs that work on other programs, and typically, if they are written in the same programming language, then typically this is done using reflection. So who uses reflection? I don't know how many of you have used reflection, or maybe just brushed on it. But basically, framework writers who want to be able to provide generic features for the framework's application. So for example, JUnit, the Spring framework, and then software tool writers. This is reflection is the bread and butter for people who deal with software tools. Aspect-J, Eclipse, all of that stuff. So a lot of basically these advanced programming techniques that typically the people who write programs for other programs or for other programmers, this is sort of the bread and butter. So I'm going to go through, explain a little bit. Almost all modern programming language these days have some reflective capabilities, although, okay, so there's a question, sorry, it's not the compilable reflection that powers autocomplete and smart features for those IDEs. That's right, that is right. So those IDEs, they use the reflection APIs in order to be able to basically model, right, the program. So you have, if you are Eclipse and you are editing a Java program, what Eclipse does is to have a model of that Java program inside, right? So that model of that Java program is given by the Java Reflection API. That's basically what it is. And of course, the compilers also use some of those facilities, because the compilers also model, you know, classes and methods and stuff like that. And so compilers are also software tools. So basically, every time that you write a software tool, which is a program that works on other programs, one way or another, especially when you write it in the same programming language, it's very convenient to use the reflection APIs of that programming language, because it already has a good model for the programs in that language. So as I was saying, reflection is some reflection capability. It exists in all modern programming languages to some extent. C does not have reflection capabilities at all. C++ has it's not very good. It has some sort of meta programming in the form of templates, but not quite. It's not really full reflection. So C++ also does not have reflection as such. But other than C++, you know, you have it in PHP, of course, Python, Ruby. The dynamic languages tends to also have a lot of reflection capabilities. Java, C#, Rust probably also has it. So these days, right? So for language don't have reflection, how do IDEs work that? So that's a good question. So IDEs, let me focus on the IDEs. So IDEs, for example, so take a Visual Studio. Okay, so Visual Studio Code, which is a really good IDE. So you have editors for. So Visual Studio Code, I assume, is probably written in C# or something like that, or maybe whatever it is. So let's assume that it's written in C#, right? So when we are editing a C# file, it's very, I don't know how, you know, I haven't seen the source code, but it's very likely that the Visual Studio uses the Reflection API to model the program, the C# file. Okay, the C# program, the entities, the classes, methods, and stuff like that, because the Reflection API is just that's what it does. It models those objects, right? But when the Visual Studio editor is editing, for example, a Java file, then because it's written in C#, it's not going to use the Reflection API of Java, because it would have, you know, that is for programs written in Java, right? So it's going to have to model the same things of Java, but using C#. You know, they have their own model of what the program in Java looks like, right? So, for example, for Visual Studio, if you're editing C++, Visual Studio does its own model of what C++ looks like, right? What's a class, you know, a method, things like that. So basically, what is reflection is a model of the concepts of the language in its own language. Okay, so there's the notion of in its own language. You can also model in another language. You can model the concepts of another language. That is not really a reflection as such. It's just a kind of a model from you know, an external language. It's only when you model the language that you are writing within the same language that you really call reflection. Yes, exactly. Use reflection when it can, because it's already it's basically a model. It's already ready for you to use. Yeah. So I will show some examples of reflection in some of these languages, but in modern programming languages, when I say modern programming languages, I say languages that are somehow compiled into an intermediate representation, and some you know, some bytecodes of some sort, which is most modern languages do these days. What happens when you have a program text, for example, class A, class B? What happens at runtime is that at runtime there are objects that represent those classes. Right? So there are objects that represent the class and the methods and the fields and everything for those those texts that you define the classes and the methods and stuff like that. And as the program executes, the Java virtual machine or whatever, the virtual machine, C# or Python, whatever, the virtual machine works on those objects that represent the code. Right? That's how it it's capable of doing, all sorts of things. So C++ doesn't do that, right? So that's why the reason why C++ doesn't, it's the reason and it's the consequence. C++ doesn't have reflection because it compiles everything down to the native code, right? So when you compile everything down to Ready code, then what you have at the end is just, basically assembly code, and you kind of lost the concepts, the high level concepts like classes and methods and stuff. It doesn't exist anymore in the compiled code. But when you compile things to an intermediate representation, typically those concepts of the language are preserved in that intermediate representation. So you have classes, right? And those classes are represented by objects at runtime. You have methods. The methods are represented by objects at runtime. Okay, so because it's very convenient. It's the reason why we do this is because it's very convenient for running programs like this. So I'll just show you. PHP is not a very nice language, and it's an old kind of web programming language, but it has a lot of stuff, including reflection. So something like this. So you have a class parent with a method foo, and you have a subclass of that class with a method bar. And some constructor, and then so this is a PHP program, right? So you can you have the capability, reflection capabilities come in every language has its own flavor of the reflection API. So this one you create the reflection class in PHP, which is something that exists in the standard library of PHP. And you give it a name, my child, right? Which is, so you're basically saying, okay, give me a reference to the class called my child, which we have defined here, right? So you have a reference for that. Yes, so Aditya asked the question, for language like Golang that compile to native code and still support reflection, there is a reflection library, exactly. So it is possible to do that reflection even if you compile it to native code. Okay, you have to do the extra effort of actually having those data structures at runtime that are available. Yeah. So here's then once you have the reference here, once you have the reference to the my child class, which is represented by some object of some sort at runtime, then you can do things like use the reflection API to find out if it's abstract, whether it's final, whether it's an interface, whether it's an instance of the class child, right? Then you can create another one for my parent and etc. Basically what this means is that there's methods as an API to access the properties that are typically declared in the program, right? And then so there's a programmatic way of accessing those properties, right? And this opens up a whole new door to programming. Ruby is an interesting example. I've talked about Ruby here and there because Ruby is a radically dynamic, radically object-oriented, radically reflective language. It's very radical, Ruby, on what it does. So, but here's this example that I have here is an example for reflection in general, not just for Ruby. Okay, this is an example for motivation for reflection. Assume that you want to create a class instance at runtime, but the name of this class depends on the parameter being passed to a function, right? So you want to instantiate something, but that something depends on some runtime parameter that you get. Now, a typical way of doing this is by having a conditional, right? You have, right, if the parameter equals foo, then you instantiate the class foo, else if it's bar, then you instantiate the class bar. So it's a very ugly kind of conditional. But another way is that if the contract of that method is that the argument is actually meant to be the class name, okay, if it's a true class name, then you can use reflection to just create that class given the name. Okay, you don't need to have that conditional. If this is called foo, then create the class foo. If this is bar, then that goes away. You just create immediately an instance of the class for which you got the parameter by, as a string. So in Ruby, you can use reflection to find out what classes already exist, information on the methods of those classes, inheritance, etc. In fact, there's a whole thing in Ruby called the object space that it basically, which is the heap where all the objects are. Ruby gives you an access to all the objects in the heap, which is really kind of amazing. And I wish many languages more would also have that facility, right? So if you think about it, when you create objects in Java or C# or whatever, or even in Python, you create a bunch of objects, but if you remember to have a reference for them, then you can access them. But if for some reason you don't have the reference for them, then you cannot access them. You cannot search for them, right? You cannot search for them. You know they are there in the heap somewhere, but somehow they're not in scope of the method that you are on right now. So in Ruby, there is this concept of basically I would call it a database, not really a database, but it's basically the object space where all the objects are. It's the heap, and the heap gives you an API to search. You can search for things in the heap, which is really cool. Or iterate through all the objects in the heap, for example. So for all the objects in the heap, you can do stuff, right? Which means that then you can search whether they have certain properties. This is a kind of a cool thing. So let me, find methods in the same way. Right, so Fraction in Java is one that I'm going to focus a little bit more and give you some examples, because I bet many of you use Java. And the reflection capabilities in Java are very similar to the reflection capabilities in C#. So it's almost identical. There's some minor little differences, but they're very, very similar. So one of the most important things is that you can, given a string that represents the name of a class, you can get at runtime a reference to that class object. Okay, so that's a method called class. It's a static method on the class. Okay, there's a class. Welcome to reflection. That's in the JavaLang package. And so that class has a static method called forName that if you give it some name, okay, it's a fully qualified name, then it gives you, if this class exists, if it's loaded, then it gives you a reference, okay, which is an instance of the class. And then you can access, you can query things, okay? You can inspect what methods are there, what annotations are there. You can access lots of properties of the declaration of that particular class, the methods and stuff like that. So or another way of obtaining the class is by, in this particular case, it would be a string, right? So a string, something, if you have some object and then you say get class, then you get the class of that object. Or like this, dot class. Okay, some object and then dot class, it also gives you the reference to the class of that object. So before I go into practical user reflection, let me just show you an example of the mechanics of reflection. I have a program here that I use to explain this. And so the reflection API in Java is in a package called JavaLang Reflect. Okay, this is where all the goodies are. And so in there, if you study this API, you will see classes defined in there that model a Java program. So there will be a class, there will be a method, a field, the constructors, all sorts of things that, the obvious things that you're going to need to model what the Java program is. Interface, things like that. I'm importing this because we'll use it. So, and here I'm defining just, what's called the base program, some basic code. So I have an interface, parameterized interface. I have a class that implements that interface for integers, other with memory. I don't remember what this is. I think it adds the last value, right? So if you say add, it adds to the last value. So it has two methods. Then you have a rectangle that also implements other rectangle, then what this does is it adds to rectangles. Okay, so it just adds to rectangles. And now we have the main method over here, and this is the part that is just plain vanilla. Okay, you just create another object, either with memory, and then you create rectangles, and you add this is not reflection. Up to here there is no reflection. Let me just show you if I can. Maybe can I comment this whole thing out? There's no way of commenting this out. Does anybody know how to comment a block of text in REPL?
Just press Control/. I think that should work.
Yeah. Let's see. Ah, excellent. Thank you. Okay, so I'm just going to run this thing that there's no reflection here. Okay, and I have a what 107. I forgot to comment something. Okay. Duplicate class main. Why is it a class main? What? Okay, this is called spider webs. Spider webs in the code. What's the problem? Did I have another class main here that I'm not seeing? That's weird. Oh. Okay. All right. So, okay, let me just compile. Yeah, all right, because I have all these other things inside these other folders. I didn't think that this guy was going to compile everything. Apparently it does. Okay, so let me try to compile just this one, Java cmain.java. All right, and now if I run Java main, I get, no reflection, nothing, just the regular things. Okay, so now I'm going to start using reflection, and I'm going to do it slowly. So the first part of there's basically several levels of reflection. The first level is what's called introspection or inspection. Okay, it's just the ability to see what's there. Okay, just the ability to query, basically, is this there, or what is there, or iterate through some things that are there, basically. So here's the first thing that I'm going to do. I'm going to ask for a class name. Okay, and then it's going to get information about that class name. Okay, so notice that I'm getting a class name from the user. So I cannot, when I write the program, I cannot know what the class that the user is going to have here. So I have to do it via reflection. So here's what I'm going to do. I'm going to, you know what, I should have uncommented this. Hold on here. So I'm going to get the class given the name, and then I'm going to get the interfaces of that class and print them out. And then I'm going to get the fields of that class and print them out, and the methods of that class and print them out. Okay, so let me remind myself of what the class names I have: rectangle and other with memory. Okay, so let's compile again. What did I forget to comment? Oh, okay. Now this guy is needed. Okay. All right, so now if I run Java main, printing that, and then enter class to inspect. So let me say rectangle, and blah, it gives me the information about rectangle. So it has an interface name adder, found the field called name. Let me look in here. Yes. It found all of these methods, and I will talk a little bit more about this. Add, get, length, 3 weight methods, 1 equals, and a bunch of methods here that are not directly defined in this class, as you can see. So what is going on in here? So let me go through the code a little bit more careful. So the first thing that I did after I entered the name is to find a reference to that class. Okay, so and I use the class for name. Okay, so given the string rectangle, it gets the class. If it exists, it gets the class of that name that has that name. And then if it exists, if the class not null, then I can get the interfaces. This is basically using the reflection API. So these are methods of the class. Okay, so you can explore this in this API. Get interfaces, and then for each one I print it out. Get the fields, and for each one I print it out, and get the methods, and for each one I print it out. Now, note some little details that when I get the fields, the only field that I really got was the field called name. And the reason for it is that the name, if you look careful here in this class, it has 3 fields, but 2 of them are private, and 1 of them is public. So the Java Reflection API only allows you to inspect the public methods, not the private. Forget about the protecteds. I don't remember if it allows you to access the protected methods, but definitely that does not allow you to access the private methods, which is a little weird. This is one of the difference with C#. For example, C# allows you to inspect everything, including the private methods. So every reflection API has its own little, decisions, micro decisions about what to show, what not to show, and stuff like that. Now, with respect to the methods, if you look into the definition of this class, I have 2 methods, add and get length and get width, and they are definitely here, add, get length, and get width. But you see lots of other methods that are not here. So where do they come from? What are all these methods? So any ideas? What are the obvious places for these methods come from? Yeah, exactly. This is superclass is the interface is and the object itself, right? The top of the hierarchy. So they all come. It shows you. So basically, the get methods gets you all the methods that are available in that class, including the inherited ones. If you look into this API, there are other methods that only give you the declared methods in this class. There's lots of details. You just need to find, there's for whatever you want to do, there's probably a method that does exactly what you want to do. So there's a method for giving just the declared methods in the class. This one gives you all the methods that are available. All right, so this is what's called introspection or inspection. It's the ability to just access something that's there and to inspect it, to see what's inside, okay? It's not acting on anything or changing anything. So now we're going to go to a second part, which is knowing what's there and being able to access what's there. Let's execute the program, certain things reflectively, okay? And by that, I mean, for example, invoking methods reflectively. Okay, this is still not changing things. So, but it's the ability to invoke a method. For example, suppose that as I was asking for the in the input what class I wanted to inspect, I could also ask what method do I want to run, right? I ask what method do I want to run, and I give the name of the method, and only then do I know the name of the method, right? And so then I need to invoke that method, and the only way that I can invoke it is using reflection. Okay, so in this particular case, I'm actually not asking for the user to input the name of a method, but I'm just hard coding it directly, which is sort of defeats the purpose. I should actually improve this program to also ask the user on the console. But apart from that, here's what I'm going to do. So I'm going to get the class of rectangle1, which was created up here. Okay. And then I'm going to declare the method add of that class. Okay, and this is the part that this thing could come from, the user on the console. And then I'm going to invoke it. So this is the famous reflective invocation. So I'm going to invoke to run a method, to call a method by using reflection, not by the normal thing, which should be r1.add r2, which is in this comment over here. But what I'm doing is I'm doing the same thing, but reflectively. Okay, so let me compile. Let me run. Rectangle. All right, so, and basically here's this last print statement. Rectangle dimensions this thing. So I called the method reflectively. Okay, this is extremely powerful. Okay, so reflective invocation is extremely powerful. So for things like, for example, for proxies. Okay, so proxies are classes that wrap around another class and they do maybe something else just before they actually delegate to the inner method. Okay, so if you want to make a proxy that is basically just totally generic, a proxy method that is totally generic. Okay, it's basically for each of the methods of the inner class. You call something, a log or something like that, and then you invoke them, right? And you don't need to have a very long list of all the method names explicitly. You just invoke, the method itself using reflection like this. Okay. So reflection is a super powerful thing that all people who are at some point going to write programs for that use other programs or that manipulate other programs, you need to know about these concepts of reflection. And as I said, this is particularly important when you are doing a software tool that in a language that you are which programs you are manipulating, right? So then you use reflection because it's already a model that the language designers have done that you can use. You don't need to roll your own, basically. Okay. All right. So this is reflection. Some practical uses of reflection. I'll just show you some examples. This is super powerful stuff. Okay, so once you understand reflection, you will feel like you've gained superpowers into programming. Okay, there's stuff that you before you know about this that you have to write a lot of like boilerplate code. And suddenly you discover that you can do this reflectively, and then your boilerplate, your very long lines of code that like looks the same can be shrunk into like 3 lines of code, basically, using reflection. I'm going to show you an example. Database access. So database access is always marrying code and databases is always a difficult thing to do, because you end up with stuff in all of the languages that I know. You end up with, here's your program in whatever. I think this is using Java. Yeah, Java. It could be C#. I've done it using C#. But you end up, here's your host language, Java or C#. And then you have to have these SQL statements in quotes, right, that are not compiled or checked or anything, and you kind of cross your fingers that you don't have a syntax error in your SQL statement. And not only that, but if you have a database with lots of tables, right, you kind of tend to feel, or you think that you kind of have to have a wrapper, a class for every table of your database. So if you have, customer table, you have some customer class that basically is the bridge between the database data and the rest of your code, right? And that's sort of the first approach to how to access the relational data in an object-oriented programming program. So the object model, basically there's duplication of knowledge of the tables, right? Typically, when you do that thing that you have a class in your program that models a table in the database, very often, and especially if you want to be consistent as you should, the fields of that class end up being exactly the names of the fields of that table. Right, there's almost a one-to-one mapping of what the fields are and what the table is. So there's a lot of duplication of knowledge, a lot of surface for errors and mistakes. It's not very pretty. Typically, the layers of database access of object-oriented programs are not pretty. So, however, you can do a lot of very powerful stuff and reduce your code to about 10% or less if you use reflection. And I'm going to show you an example, and I think this is C#. So instead of having a table handler that for each table, a separate class for each table of your database, you can have just a one generic table handler that is parameterized on the type. Okay, I use a little parameterization. You parameterize, you just have a generic table handler. And what this generic table handler does is it reflects on the type, right? And finds all the fields declared in that type reflectively, right? So it goes, you have a type, whatever, customer, right? And you define the fields of customer in there. And so in here, in this generic table handler, you don't need to repeat that for constructing your SQL statements or anything. You just know that you have those fields. You get that reflectly for every class, right? For every type of object in your application. And then you basically iterate through them, right? So you iterate through them for doing all sorts of things. So you can have, for example, an instantiation of the table handler for some, group data, for some personal data or something like that. Okay, so here's the group data. And then you can have in the generic table handler, you can have a generic get method, which is, get, it's basically the SQL statement, get something where some field equals some value, right? And you can have an and some other field equals some other value. Yes. So you can have that very generically here, with just, again, parameterizing on the type. And so you say add for each of the fields that you get on the where clause, right? You add the parameter for that query where field equal value, right? And field equal value, and then and basically you join the where clauses, and then you just do a do query. And this is a completely generic get method for any type of data of your application that corresponds to a data in the relational database, etc. So this is and then when you do the query, right, you get the data. You get the data, and then you read each of the rows, right? And you know that when each of the rows is going to correspond to the type that you have parameterized the generic class, right? So you have a new T. So here's using sort of reflection too. And then you fill that instance that you are creating, again, knowing by reflection that you knew already what were the fields of that class. And so you just whatever column you have, you just fill it out on the field of the object, and voila, you basically just were able to access any type of data from the database to create the corresponding objects in your application with just one class generic table handler instead of many, and that's a good thing. So this may be a little too, what I just explained, maybe a little too abstract for those of you who have never had to deal with this problem of database access from object-oriented programs. some of you maybe have already had that experience, and maybe you know that is not a pretty part of any code base. And you know, and this is not an extensive and detailed way of explaining how to do it, but it just gives you, point you in that direction. Look at reflection for solving these kinds of problems. Whenever you see boilerplate code, basically rule of thumb, you see a lot of boilerplate code that looks a lot the same, maybe it's just the types that are different or something like that, then you should probably look into simplifying that entire thing using reflection. Now, the not so pretty part of the story is that there is a performance penalty when you use reflective APIs, obviously. Okay, so I mean, you look at this, right? So I'm using invoke, right, as opposed to r1.add. So invoking methods by itself already has a little bit of penalty because it's dynamic dispatch. That runtime, you need to find out where the method is. I already explained that. Using reflection, it's even more, right? Because now you're going through the reflection API. First, you're not invoking the method directly. You're invoking a method invoke that is going to look up more things about where that object is and where the method is. So there's a lot more, overhead in invoking the method reflectively. So keep that in mind. That reflection is very powerful, but it comes up with a performance penalty. So if performance is an issue, you don't want to use reflection. If, for example, one thing that kind of bites you, again, this is systems programming. For those of you who have had any experience of doing distributed programming, one thing that you need to do is to package the data, right? Serialize the data, serialize and deserialize the data. So you serialize the data to send it over the wire, and then on the other side, you receive a stream of bytes, and then you have to deserialize it to create the object, right? So typically that can be done very nicely using things like the serializable interface or something like this that uses reflection. To do that, you basically don't need to worry about. Basically, if you have an object with some fields, you don't need to do wrappers and then wrappers of that object, or serializes and deserializes of that object. You just reflectively you find out what are the fields. So for each field, you just write the data onto the onto the buffer, and then the other way around, you get the buffer, and then for each field you just get the data out. But that has a very, it's very convenient because it's very short amount of code. But in the cases of a network operation, and especially if latency is an issue, then serialization really adds up. It's a big chunk of where the time spent is. So serialization is something that you need to be aware that you can use reflective APIs to do very powerful serializations where you write very little code, but it comes with a penalty that you may not be able to accept. Okay. Another warning is security. Okay, so reflection requires runtime permission in most languages, not all, depending on the languages, but in Java certainly does. That it requires some runtime permissions that it may not be there. Okay, so if you assume that you write something that you use reflection and that runs on some other person's site, and the security manager is not giving permission to your library to use reflection on those classes, then your code will fail. So it's something that you need to have that into consideration. And exposure of this as a writer of programs. Okay, now as a writer of programs, you yourself should be aware that your code is subject to reflective analysis. Okay, so if you write some piece of Java or C# or something, okay, and you wrap it up, you compile it, and you think that you've done your maybe you didn't think much about public and private and protected qualifiers, right? And maybe you put all the methods are public, or all the methods are public, all the fields are public, keep in mind that that comes with some security problems. That if somebody can reflectively see what your classes have inside and basically inspect your code, know everything about your code. Reflection allows code to perform operations that would be illegal in non-reflective code, such as accessing private fields and methods. I've done this myself sometimes. I was using some library and I really wanted to change the value of some private field, and I couldn't change it because it was private. But I really wanted, so I basically, used reflection. This was in C# that allows you to access the private fields. So keep that in mind, that some of those things about the visibility keywords are rendered useless once you have the power of reflection with the right security permissions.